Why do microservices need a circuit breaker pattern? Imagine a busy city with many roads connecting different neighborhoods. If one road gets blocked or congested, traffic can back up and cause delays everywhere. That's similar to what happens in a microservices system when one service starts to fail or slow down. Microservices are small, independent parts of a larger application, and they often talk to each other over the internet using application programming interfaces. Because these services depend on network calls, they can run into problems like unresponsive services, slow responses, or even complete outages. When one service fails, it can cause a chain reaction, making the whole system sluggish or even crashing. This is where the circuit breaker pattern comes in. Think of it like a safety switch that protects your system. When a service keeps failing or not responding, the circuit breaker trips and stops sending requests to that service temporarily. This prevents the calling service from wasting time waiting for responses that might never come. Instead, it can quickly return a fallback response or an error message. The main reason microservices need this pattern is fault isolation. If one service fails, the circuit breaker keeps that failure contained so it doesn't spread across the entire system. This helps keep the rest of the system running smoothly. It also improves availability because it allows other services to continue functioning even if one is having trouble. Another reason is load management. When a service is overwhelmed or failing, the circuit breaker reduces the number of requests sent to it. This gives the failing service a chance to recover without being overwhelmed further. It also speeds up failure handling because it stops waiting for timeouts or repeated failed attempts, which can waste resources and increase latency. Plus, circuit breakers have a self-healing feature. After a cooldown period, they test the service with a few requests to see if it has recovered. If the service responds well, the circuit breaker resets and normal operation resumes. If not, it trips again. In real-world backend development, especially when working with APIs, databases, and server-side logic, the circuit breaker pattern helps keep microservices responsive and reliable. It supports graceful degradation, meaning the system can still offer useful responses even if some parts are down. Implementing circuit breakers does add some extra work, like managing fallback responses and monitoring the state of the circuit. But the benefits of a resilient, scalable system far outweigh these challenges. Many tools and libraries now include built-in support for circuit breakers, making it easier to add this pattern to your architecture. To sum up, microservices need the circuit breaker pattern to handle the unpredictable nature of distributed systems. It helps prevent failures from spreading, keeps the system available, and ensures users get a good experience, even when some parts of the system are having trouble.